Before dawn, the world is a silhouette of sound. A small team moves like a shadow across salt-slick concrete and dew-soaked scrub. One figure shoulders a rifle that looks familiar at a glance, an AR pattern platform, yet something about its balance, the quiet geometry of its barrel and handguard, the way the optic catches the low light, marks it out from the newer rifles on the backs of the others. The team slips into position. Breath slows. The man with that rifle breathes out, finds his sight picture, and trusts the gap between him and the target to a tool whose roots run back decades. Why choose that weapon when sleeker newer platforms promise every upgrade imaginable? If you like deep gear dives, subscribe. We do these investigations regularly. This is not a story about nostalgia or stubbornness. It's about the unseen calculus that lives at the intersection of human skill, predictable engineering, and the unforgiving math of ballistics. It's a forensic look at a particular family of rifles, commonly called the Mk-12 Special Purpose Rifle, and the reasons some operators still pick it for precision work when modern alternatives sit on the equipment racks. The answer is not a single line item. It's a braided rope of technical advantages, training realities, logistical friction, and what operators call confidence. Origins. Why the Mk-12 came into being. The Mk-12 was born of a simple professional need. Provide an infantryman the precision of a long-range rifle without the size, weight, and length penalties of a dedicated sniper system. In the late 1990s and early 2000s, amid changing combat zones and new mission sets, units needed an intermediate solution. A rifle more accurate than a standard carbine but still mobile and quick to shoulder. The SPR concept filled that niche. A purpose-built precision AR variant optimized around a longer, heavier profile barrel, refined components, and optics suited to mid-range engagements. Across the decade that followed, public reporting and defense press documented iterative refinements to that concept. Match-grade barrels and chambers, free-floating handguards to avoid disturbing barrel harmonics, carefully chosen twist rates and ammunition to stabilize heavier projectiles, and optics chosen for clarity and rapid engagement at varying ranges. In short, the Mk-12 concept focused tightly on predictable precision and a consistent point of impact under real-world conditions. What matters in the field? Anatomy of a precision AR. To understand why an operator might prefer one rifle over another, you have to follow the chain. Each component, each choice, ultimately contributes to where the bullet lands under stress. When heart rate is elevated, when light is low, when the sea spray is in the air. Barrel profile and length. Precision starts with the barrel. Heavier, match contour barrels resist overheating and vibration better than thin, carbine-length barrels. A stiffer barrel tends to alter its vibrational behavior less as it heats with consecutive shots, producing a more predictable point of impact. Barrel length interacts with muzzle velocity. Longer barrels can extract a bit more speed from a bullet, smoothing external ballistics. Those changes are incremental, but at ranges where precision matters, hundreds of meters, incremental changes add up. Twist rate and bullet stabilization. Twist rate refers to how quickly rifling spins the bullet. Heavier match projectiles, designed for long-range stability, need faster twist rates to stabilize. Matching twist to the chosen ammunition reduces yaw and improves long-range accuracy. In practical terms, a barrel built to stabilize heavier match bullets yields tighter, more consistent groups when those bullets are used. Free-floating handguards and barrel harmonics. The point where the shooter's hand or accessories contact the handguard can introduce microforces on the barrel if the handguard is not free-floating. A free-floating design isolates the barrel from those forces, keeping its vibrational pattern consistent shot to shot. The result is predictable groups. The same rifle, given the same input, tends to place rounds in the same spot. Trigger embedding. A crisp, consistent trigger break enables better control over the release of the shot. Match triggers, carefully tuned for travel and break, reduce a shooter's inadvertent inputs that pull shots off target. Similarly, the mechanical fit between barrel, receiver, and stock, bedding in long rifle parlance, matters. Anything that shifts between shots introduces variability. Optics and sighting philosophy. The Mk-12 concept typically pairs a higher quality optic than a basic issue red dot or 1.4x scope. The philosophy is clear: give an operator magnification and reticle features suited to identifying and engaging targets across a broader envelope. But optics are more than magnification. Mounting consistency, repeatable zero, limited parallax error, and reticles that support quick holdovers are all part of the package. A shooter who trains with a specific sight picture will build reflexes around it. Changing that picture alters split-second decisions. Suppressor compatibility and gas system considerations. Suppressors alter back pressure and gas dynamics. Platforms originally optimized for a given gas system and muzzle configuration can behave differently when suppressed, affecting dwell time and felt recoil. Compatibility and predictable adjustment are important for teams that rely on suppressed fire. The Mk12 builds that remained in use tend to have known, tested suppressor pairings and tuning practices, reducing surprises in the field. Mission fit, bridging the carbine and the sniper rifle. The Mk12 sits in that sweet spot between a carbine and a bolt-action sniper rifle. It's intended to be more precise than a typical service carbine at medium ranges, while still retaining the rapidity and adaptability of an AR pattern weapon. For many mission profiles, rooftop overwatch in urban terrain, maritime interdiction where mobility matters, or counterinsurgency patrols that can suddenly escalate, a platform that combines precision with speed and modularity can be decisive. Newer platforms and the theory of improvement. Modern rifles offer tempting theoretical advantages. Short-stroke and long-stroke gas piston systems, found in some contemporary designs, can reduce the amount of carbon and fouling driven into the receiver, theoretically improving reliability in extended sustained fire or difficult environments. Multi-caliber systems promise the flexibility to change cartridges for different missions. Improved materials and manufacturing techniques yield lighter, stiffer components, all attractive on paper. But the devil is in the operational trade-offs. Different gas systems create different recoil impulses and bolt carrier dynamics. A piston system's impulse can feel different to the shooter and alter rapid-fire follow-ups. Multi-caliber adaptability introduces complexity. It requires more parts in the supply chain, more armorers' time, and more range hours for operators to become fluent with multiple ballistic envelopes. Newer platforms often change ergonomics, rail interfaces, stock geometry, or optic mounting that shift the sight picture and muscle memory of a trained operator. Human factors, muscle memory, confidence, and the sights you know. A rifle is ultimately an interface between human intent and the external world. You can measure barrels and chamber dimensions, but there's a quiet power in an operator who has honed reflexes around a particular sight picture, trigger feel, and stock geometry. Muscle memory is literal. Thousands of repetitions train the body to make micro-adjustments without conscious thought. Imagine a violinist and a bow. A professional can coax nuance from a familiar bow. Hand them a newer, lighter bow and the same piece will sound different until the musician relearns small tactile cues. The same happens with rifles. Under stress, elevated heart rate, constrained time, operators rely on ingrained motor patterns. A sight picture they have practiced to reflex is a fraction of a second advantage. That fraction can mean the difference between mission success and failure, or between life and death in extreme cases. Training continuity compounds this effect. Units spend countless hours on weapon drills, marksmanship courses, and live-fire exercises. Transitioning platforms requires training hours, requalification cycles, and the institutional patience to accept short-term reductions in proficiency while the force ramps back up. For elite units that operate across many theaters, that time has a real opportunity cost. Logistics and armors, the invisible scaffolding, weapons don't function in a vacuum. Armorers, those technicians responsible for repair, tuning, zeroing optics, and managing spare parts, are a critical part of the equation. If a rifle platform has an established inventory of spare barrels, gas blocks, handguards, and mounts, armorers can keep a fleet mission capable with predictable turnaround. Introducing a new platform changes supply lines, new proprietary parts, new torque specs, new calibration procedures. That creates a period where the armorers and supply clerks learn the system and increase parts inventories. For small, frequently deployed teams, That transition risk can be a practical reason to retain a proven system, especially if the existing platform already meets most mission needs. Maintenance characteristics also matter. A gunsmith assessing two platforms will compare how they tolerate salt, sand, and neglect, how easy they are to disassemble and reassemble cleanly under stress, and how robust their accessory interfaces are. Historically, Mk-12-style systems were valued because their components were well understood and supported by a network of armorer know-how and civilian equivalents, which eased maintenance in diverse theaters. Forensic evidence. What the tests and open-source reports say. We move from analysis to evidence by looking at the publicly available testing and reporting that informs this conversation. Independent range tests and defense journalism over the past decade have shown a recurring pattern. Purpose-built precision ARs with match barrels and matched components routinely deliver tighter groupings than stock carbine-length rifles when both use comparable match ammunition and are tested under controlled conditions. That's intuitive. Better barrel, controlled harmonics, tuned triggers. But it's also measurable. Some open-source tests demonstrate that precision AR builds can produce group sizes consistent with the expectations of minute of angle, MOA, or better performance in controlled ranges with match-grade ammunition. It's important to qualify those statements. Most controlled tests are performed by civilian testers or defense-oriented media and are conditioned. Single-shooter, bench-supported groups, specific ammunition, and tuned barrels. Performance on the range does not automatically translate 1.1 into the field, where environmental variables, movement, and stress introduce variability. Yet repeatable evidence of platform precision does matter. It says a rifle can be counted on to deliver a predictable point of impact under known inputs. When durability and reliability are tested, salt fog, continuous firing cycles, or sand exposure, reports vary and are platform dependent. Piston systems often show an advantage in limited tests regarding reduced fouling in receivers. But other factors, material quality, finish treatment, and maintenance practices, also determine how well a system tolerates abuse. Published armorer interviews and maintenance logs available in the public domain frequently emphasize that predictable wear patterns and known fixes are as valuable as marginal gains in time between failures. Two anonymized vignettes help illustrate how these technical and human factors converge. Vignette A. The Overwatch at First Light. A small Overwatch team establishes an elevated position overlooking a congested urban approach. The team's task is observation and, if necessary, precision engagement at ranges where a standard carbine's dispersion could be the difference between missing and hitting an intended target or harming bystanders. The designated marksman shoulders an Mk-12-style rifle. Over several hours, the shooter engages in holdover practice, verifies 0 after each environmental shift, and records consistent point of impact across a series of known, repeatable shots. The rifle's predictable behavior, consistent trigger feel, familiar sight picture, and the ballistic performance of the chosen ammunition keeps the shooter's confidence steady. During a high-stakes window later that day, the operator must make a single precision engagement. The shot lands where training and equipment predicted it would. Vignette B. A maritime boarding exercise. During a simulated interdiction at sea, salt spray and corrosive atmosphere test every piece of gear. A team member transitions from an M4A1 style carbine to a precision AR for the boarding's Overwatch element. The team had rehearsed suppressor pairings and known the rifle's behavior in the maritime environment because their armorers had experience maintaining the platform in similar conditions. In the simulation, optics held 0, the rifle cycled reliably, and the suppressor pairing behaved within expected tolerances. The team credits the predictability of the tested platform and the cumulative field-proven adjustments made over time. Neither vignette is evidence of universal superiority. They are, however, shorthand for how multiple small, empirically supported advantages translate into operational confidence. Comparative trade-offs spelled out. Let's make the trade-offs explicit, comparing the Mk-12 concept with a few broad newer platform categories. Gas piston ARs. Pros: reduced receiver fouling in some test conditions, potential reliability gains in sustained fire or very dirty environments. Cons: altered recoil impulse and carrier dynamics, sometimes greater parts complexity. Differences in maintenance and unique parts can complicate logistics and armorers' workflows. Multi-caliber systems. Pros: flexibility to tailor ballistics to mission demands, ability to switch cartridges for longer reach or heavier projectiles. Cons: increased part inventory, more training required to master multiple ballistic solutions, more room for human error in swapping components under stress. Newer AR variants with modern modularity and lighter materials. Pros: improved ergonomics, often lighter, and designed with contemporary accessory ecosystems in mind. Cons: lighter can mean less thermal mass and different harmonic behavior. New ergonomics alter sight picture and muscle memory. Proprietary interfaces can lock a unit into specific accessory suppliers. In all these comparisons, we must reiterate a central theme. Theoretical technical improvements are necessary, but not sufficient. The combined cost of retraining, resupply, changing maintenance protocols, and accepting a period of reduced proficiency can outweigh a marginal performance gain, especially when the existing platform demonstrates reliable, documented performance within the mission envelope. Why still use the Mk12? The convergence of factors. So why do some teams continue to field Mk12-style rifles years after their inception? The answer is not stubbornness, it's convergence, predictability. The Mk12's design philosophy prioritized repeatability in the variables that matter most to precision. Barrel stability, matched ammunition, consistent sight picture, and suppressor pairings. Predictability reduces unknowns in stressful conditions. Training and muscle memory. Elite operators invest hours to make their responses automatic. Changing platforms takes time that may not be available or desirable when the current rifle meets operational needs. Logistics and armorers. A field-savvy armorer corps with parts, experience, and established repair procedures is an underestimated force multiplier. New systems demand new supply chains and new technical familiarity. Operating environment and mission fit. The Mk12 family was conceived for specific use cases, designated marksman roles that require more precision than a carbine without the bulk of a bolt gun. Where missions still call for that envelope, the rifle retains relevance. Field-proven modifications and iterative refinements. Over years of use, particular configurations, optic choices, suppressor pairings, gas tuning, become tried and true recipes. Those recipes travel with the rifle. Replacing the platform discards institutional knowledge. Institutional conservatism versus wise restraint. Institutions often get painted as slow to change. In reality, prudent forces balance the promise of new technology against the immediate realities of mission readiness. An organization that rapidly replaces systems without careful rollout risks transient capability gaps. An organization that refuses to test new tech at all risks obsolescence. The Mk12 story is not a manifesto against innovation. It's a study in measured adoption. When newer designs truly deliver a material improvement after accounting for training, logistics, and human factors, they are adopted. But newer is only an advantage when the whole system, man, maintenance, supply, and tactics, moves with it. A caution on evidence and claims. You will read a range of claims in open sources, some more precise than others. It's important to be critical. Bench rest accuracy numbers, for example, are valuable but should be read in context. Controlled, often static conditions using a specific load and a rested bench do not equal dynamic engagements. Likewise, anecdotal praise from operators is meaningful as a cultural indicator, but anecdote alone is not a statistical proof. Where public tests exist, independent shooting tests, defense outlet reviews, and armorer interviews, they offer converging signals. The Mk12-style precision ARs are capable within their design envelope, and their continued use reflects a balance of practical benefits rather than blind preference. Lessons beyond the platform. This story, about a rifle kept in service because it fits a user and a mission, speaks to a larger principle in equipment and human performance. Fit matters more than novelty. A tool that is well understood, well supported, and well trained with will often outperform a theoretically better tool that is unfamiliar, poorly supported, or ill-suited to the task. Innovation should be encouraged. Skeptical adoption should be respected. The best organizations combine rigorous testing, careful rollout, and honest evaluation. They pilot new systems, Measure performance across the full enterprise of training and logistics, and then decide if the payoff justifies the cost. When it does, change happens. When it does not, prudence holds. Closing reflection. Back at first light, the team withdraws. The rifle is stowed. For the shooter, the choice made in the silent minutes before dawn was pragmatic, quiet, and personal. It was about a sight picture they have practiced until it is reflexive, about a barrel whose harmonics they understand, about an armorer who knows how to keep it functioning after 3 tours in salt and dust. It was about trusting a tool whose quirks are known and whose failures are understood. New rifles will continue to arrive, and many will bring real improvements. Some will earn their place and replace older designs as they prove their worth across the whole system. But the Mk12 story reminds us that better is not only a matter of specs on a sheet. It's a matter of who picks up the rifle, how many rounds they've fired through that exact configuration, what their armorer knows to fix at 0200 in a foreign port, and what the team can rely on when the light is thin and decisions must be fast. If you have reputable sources or test reports you think add to this story, share them in the comments, and keep in mind operational security. Avoid posting anything that isn't openly published. If you enjoyed this deep dive into equipment, ballistics, and human factors, subscribe for more investigations that blend history, tech, and the lived experience of the people who use these tools.